There is a whole spectrum of electromagnetic waves. So you can see here gamma rays are there, X-rays are there, ultraviolet rays are there. Then there is a small portion here, and then there is infrared, radio waves. This is a whole spectrum of electromagnetic waves. This small portion which is there, which we call visible region, that means we humans can see it. All right, of course other creatures also see it. So this small portion is enlarged here. This is the visible part of the spectrum. So this we refer to as light. In this whole chapter, whenever we refer to light, we mean the visible spectrum. Of course, lot other creatures can see other parts of the spectrum, but the humans cannot. Okay, so reflection of light. Anything and everything around us reflects light. How can we say that? If that was not the case, then we wouldn't have seen the objects around us. We wouldn't have seen things around us. It is only because the light gets reflected from those objects. Now, I have shown an eye here just to represent us. Okay, so we can see the moon. Why? Because the light from the moon reaches the eye. Right? Say, for example, this toy or a real aeroplane in the sky, we can see it only because the light from that object reaches the eye. Then the trees, the fruits, right? We see them only because the light from them reaches us. Fish in water, we see it only because the light from them reaches us. Now, do they produce light? No, they don't produce light. I can understand if you are seeing a flame of a candle, because it produces light, that light reaches us and we see it. If we see a lighted bulb, it produces light, it reaches us, and hence we see it. The sun, the stars, they produce light, and that light, when it reaches us, we see them. Right? But do these things produce light? No. Then how do we see them? That is because the reflected light reaches us. All these objects around us reflect the light, only then we can see the objects. Even the dark, whether bright objects or dark objects, we see them only because they reflect light. Suppose this is a plane and this is a normal, means this is perpendicular to this plane. Now if this incident ray makes an angle with the normal, that angle we call as angle of incidence, generally denoted by I, or say theta. The angle made by this incident ray with the normal is called the angle of incidence. That means we measure angle of incidence from the normal. Then what about angle of reflection? Again, it is from the normal. Okay? Since we understand that angle of incidence, angle of reflection are measured from the normal, let's revise the laws of reflection. So first law, the angle of incidence is equal to angle of reflection. And second one, the incident ray, the normal to the mirror at the point of incidence, and the reflected ray, lie in the same plane. To understand these laws, let us see some animations and also see some experiments. Say, for example, this is a plane and this is the normal. There is a ray incident at this point on this surface, and there is an angle of incidence, and we have an angle of reflection. If angle of incidence is theta, then angle of reflection is also theta. Okay? That is what it means by angle of incidence is equal to angle of reflection. Hence, if we increase the angle of incidence, the angle of reflection also increases. Let's see this animation. There is angle of incidence, there is angle of reflection, which are equal, right? If I increase the angle of incidence now, angle of reflection also increased. If I still increase it, angle of reflection is also increasing. Still increasing. Angle of incidence is increased, angle of reflection also increases. If I decrease the angle of incidence, see, the angle of reflection also decreases. Again, if I increase the angle of incidence, angle of reflection is also increasing. Let us see an experiment which demonstrates that as you increase the angle of incidence, angle of reflection also increases. Same way, as I decrease the angle of incidence, angle of reflection also decreases. So let's watch it. In this video, you can see a plane mirror, an incident laser beam, and a reflected beam. The smoke of agarbatti is used so as to make the path of the laser beam visible. You can see as I increase the angle of incidence, angle of reflection also increases. As I decrease the angle of incidence, you can see the angle of reflection also decreases. Increasing angle, decreasing angle. Right? Now, the second law. The incident ray, the normal to the mirror at the point of incidence, and the reflected ray lie in the same plane. What does it mean? Suppose there is a surface and the ray is incident at the surface at this point, right? And this is the normal, right, to this surface. Then it gets reflected. Now I can pass a plane through all these three, the incident ray, the reflected ray, and the normal. So I can pass a plane, right? That is what it means by all these three lie in the same plane. Let us see an experiment which demonstrates that the incident ray, the normal, and the reflected ray lie in the same plane. Let's see it. A plane mirror is kept in vertical position. There is a plane of the paper. A normal is drawn in that plane of the paper. A laser beam is incident on the mirror, and you can see the incident beam as well as the reflected beam lie in the same plane of the paper. Correct? Let us change the position of the plane. Let us keep the plane in vertical position, right? And a normal is drawn in that plane. Again, a laser beam is incident on the mirror. And you can see the incident beam the reflected beam, and the normal all lie in the same plane. Correct? Let us change again the orientation of the plane. Let us keep the plane in slanting position. You can see here also the incident beam, the reflected beam, and the normal lie in the same plane. Correct? I'm sure you must have enjoyed both these experiments. It's nice to watch and understand it, right? Okay, now let us see how an image is formed in a plane mirror. So, let us consider this plane mirror. Then there is an object which I have considered. The rays from the object are incident on the mirror and they get reflected, right? Here, while reflecting, the laws of reflection are followed. If we watch these rays, then it appears as if the rays are coming from this point behind the mirror, and we see a image at that point. This image cannot be taken on the screen. We call it virtual image, right? So in this animation, we saw the image formation of an object in a plane mirror, right? In this, rays coming from one point of the object are considered, and we saw how the image of that point is formed. Likewise, rays coming from every point of the object get incident on the plane mirror, they get reflected, and hence image of those points are seen behind the mirror, right? And hence we see the image of the whole object. Now let us see the properties of this image. Let us see this animation. So let us consider a plane mirror and an extended object AB. In this, only few rays are considered to avoid confusion. From every point, only two rays are considered. Alright, so see it. So the rays coming from the object are incident on the plane mirror and they get reflected. So if we see from here, it appears that the rays are coming from the object behind the mirror, right? And that we call as image. Say A dash, B dash. Now here you can see that the image formed by a plane mirror is always virtual and erect. What is the other property of the image? The size of the image is equal to the size of the object. They both are of the same size. One more property, the image formed is as far behind the mirror as the object is in front of it. Okay? Let's see one more property. See this animation? Let us consider a plane mirror and let us consider this object. Again, the rays from these objects get incident on the plane mirror, they get reflected, and it appears that the rays are coming from the object behind the mirror. That's the image, right? From this animation, what do you understand? That if this is the left side of the object, then inside the mirror, this is the right side of that image. If this is the right side of the object, then inside the mirror, this is the left side of the image. Let's see one more example of this and let's understand the property. You can see here a mirror, right? So if I take this letter D, you can see the image of it in the mirror. E, you can see the image, and B, right? So what do you understand? The image formed by a plane mirror is laterally inverted. I'm sure you must have experienced this every day when you look into the mirror. Your right hand is the left hand of the image. Every one of us experience this every day, right? So I'm sure you must have enjoyed learning this. We saw the reflection of light, how we see the objects, how we see the images formed by a plane mirror. We learned and revised the laws of reflection and also revised the properties of the image formed by a plane mirror. We'll learn more about this topic in the coming sessions. That's all for today. See you next time.